Here we are showing how to solve for torque involving a non-perpendicular force. With non-perpendicular forces, we would use the equation torque is equal to force times R times sine of phi. In this example of a wrench turning a bolt, our job is to find the total net torque created by the two forces applied at different lengths. First, we see that for force 1, there is a force of 75 newtons, angle of 45 degrees, and a length of 15 centimeters. For force 2, there is a force of 75 newtons, angle of 45 degrees, and a length of 30 centimeters. Next, we need to notice the direction of the forces. For force 1, it is seen that it is going down, making it a negative force. For force 2, it is seen to be going up, making it a positive force. With this information, we begin to create the equations, plug in, and solve. We know that net torque is equal to torque of the first force plus the torque of the second force. And torque is equal to force times length times sine of phi. Knowing that, we can create the equation net torque is equal to negative force 1 times length 1 times sine of phi 1 plus force 2 times length 2 times sine of phi 2. Before we can plug in, we need to convert the centimeters to meters. So for length 1, which is 15 centimeters, is equal to 0.15 meters. For length 2, it is 30 centimeters, which is equal to 0.3 meters. Now we can plug in the numbers and solve. Net torque is equal to negative 75 times 0.15 times sine of 45 plus 75 times 0.3 times sine of 45. We can simplify this by factoring out the 75 sine 45, which leaves us with net force, or net torque, is equal to 75 sine 45 times negative 0.15 plus 0.3. This is then equal to 75 sine 45 times 0.15, which is the new length, and then through simplification, it equals 11.25 sine 45, which when solved out equals 9.6. This means that the total net torque created by these two forces is 9.6 Newton meters.